welcome to your Level 1 Regents Review Packet. This one we will be reviewing everything that you need to know about transformations for your Regents. Now, the front page of all your Regents Review Packets will be the main concepts that you need to know. It'll have the formulas and the major topics that you learned in that unit. So if you look here on our front page, we have all these different formulas that describe different kinds of transformations. Now, I'm not going to go over them here. You just have to look at the link below this video on the website to see what these different transformations are. Just for example, if you go over here, we can say that this is a translation. You might remember that, maybe not. You could say that this is a dilation, and these are the different formulas for doing it. Remember, K is the scale factor, you multiply the X and Y, whatever. So just you take a look at that. This will tell you which ones are reflections, over which axis, the rotations are over of how many degrees. You also have your minimum rotation formula. Remember, that's if you have a figure and you want to rotate it to look exactly the same, this formula will get you there, and then you have the formula to find the scale factor. The other major topic from this unit was the difference between rigid motions and non-rigid motions. Remember, rigid motions preserve side length and angle measures. Non-rigid motions, well, they don't. Now, dilations, remember, they don't create congruent figures like rigid motions do. They create similar figures because dilations, they're not rigid, but they do preserve angle measures. So if we see a dilation pictured here, we know all the angles are congruent, all right? And yeah, those are the major topics. So rigid motions, non-rigid motions, dilations, and the formulas there. Review all this information before your Regents because these are all the major topics. Now let's go on to the next page and let's start actually doing problems. We'll apply some of the concepts that we learned in Unit 1. So we're gonna just go through these problems. Let's get it going. So for our first Regents practice problem, it says the graph below shows triangle ABC and its image A double prime, B double prime, C double prime. Remember, the double primes tells us that there was two transformations. Okay? That's what those primes tell us. Remember? Describe the sequence of rigid motions that would map triangle ABC onto A double prime, B double prime, C double prime. So to do this, remember, there's an infinite amount of ways to do it. I'll show you one way. The way I'd like to do it is I'm going to translate this triangle 2 units down. So let's write that down. A translation 2 units down. Notice how I don't just say a translation. I say a translation and how much I'm actually moving it down. I'm going to redraw that, okay, after I've gone 2 units down. All right, so I have C prime, A prime, and B prime. And now we're going to reflect it over the y-axis, all right? I know I can do that because they're equidistant from this line. They're both 2 units away from that line, so that means it's symmetrical on both sides. So then a translation, did I just say translation? Boy, you gotta be kidding me. Not a translation, then a reflection over the y-axis maps triangle ABC onto triangle A double prime, B double prime, C double prime. And remember, we know these two triangles are congruent also because we use a sequence of rigid motions to map them onto each other, and whenever you use rigid motions to map two things onto each other, you know those two things are congruent. All right, let's move on to question number 2. Moving on to 2. This one says, in the diagram below, triangle ABC and XYZ are graphed. Use the properties of rigid motions to explain why triangle ABC is congruent to XYZ. All right, we want to explain why they're congruent. So this is just like the problem we did before with some added steps. We have to not just say how they map onto each other, which there's a few ways to do it, but we also have to say why we know they're congruent on top of that. All right? So here's the deal. This transformation is pretty simple to do. This would be a rotation of 180 degrees around the origin. Remember, you need your center of rotation. And then you have to pick a direction. Now, if it's 180 degrees, it doesn't matter. So I'm going to say it goes clockwise. All right? You could say counterclockwise, you end up the same place, but you always say direction. So remember, you always need, if you're doing a rotation, you need the degree, you need the direction, and you need the center of rotation, right? This is how you describe rotations. That's super important. So let's actually write out how we would map these two onto each other. So we would say a rotation of 180 degrees clockwise around the origin maps triangle ABC onto triangle XYZ. So if you took this one 180 degrees clockwise, it ends up right on top of it. Now, how do we know they're congruent? A rotation is a rigid motion, and rigid motions preserve side lengths and angle measures. Remember, if it ever asks you to use the properties of rigid motions to explain why they're congruent, you need to state the properties of rigid motions. So the reason I know these are congruent is because a rigid motion does not change the angle measures or side lengths. So they must have mapped perfectly onto each other without changing their shapes. All right, so let's move on to the next problem, number 3. All right, given right triangles ABC and DEF, where angle C and angle F are right triangles, we know that AC is congruent to DF, and we know that CB, let's see, where's that? And FE are congruent. Describe a precise sequence of rigid motions that would show that these two are congruent. All right, so we want to map these onto each other to show that they are congruent. All right, now let's just go for it. So you might remember this question. We've done it a few times. What we're going to do is take ABC and we're going to translate it along the vector AD. So we're going to move from A all the way to D. So first we're going to do a translation along AD. Remember, if we're off the coordinate plane, we're going to use a vector. That's the line that we move along. If we translate ABC along that vector, it would go from here to here. That's ugly. I'm going to take that out. Ugly. Okay. So now that we've got it over here, we're going to now just reflect it over this line DEF. And if we reflect over DEF, I know it doesn't look like it from my picture, they will map perfectly onto each other. So then we're going to do then a reflection over DF maps triangle ABC onto triangle DEF. Pimp. Done and done. Okay, let's move on to our next problems. All right. Now, in the last skill, we were describing transformations. For this one, we're going to do transformations. Okay. So there's 3 transformations we'll do here. You've actually done them in the past. They're on your past tests. So if you want, just try doing them and then watch the video and see if you got them correct. I'd say try doing them first, all right, and then check your answer. But here we go. We'll do it together now. But I'd say pause the video, try it on your own, then check to see if you did it right. So for the first one, it says, in diagram below, triangle ABC has these coordinates. Graph and label A double prime, B double prime, C double prime. Remember, that's 2 transformations. The image of ABC after the translation 5 units to the right and 2 units up, followed by a reflection over y equals 0. So let's do that. All right, we're going to just draw this image. So first, we're going to move all our points 5 units right, 2 units up. So C is 1, 2, 3, 4, 5, and then 2 up. 1, 2, and that's our C prime right here. Then B is 1, 2, 3, 4, 5, and then 2 up, and we get B prime. And then A is 1, 2, 3, 4, 5, and then 2 up, and we get A prime. All right? And if you draw it out, of course, this looks like a slide. Now, the line y equals 0, which we're reflecting over, remember, y equals is always a horizontal line. So that's this line right here. So to reflect over y equals 0, there's 2 things. Either you could change the sign of y for each of your coordinates, or you could just count how far you are away from this line. So you might remember this. So I would count 3, 1, 2, 3 to the line, and then I'm going to go 3 on the other side of the line. So that's B double prime. Do the same thing for A, 1, 2, 3. 1, 2, 3. That's A double prime. And then C, 1, 2, 3, 4, 5, 6, 7. So we gotta go 7 down now. 1, 2, 3, 4, 5, 6, 7. And that's C double prime. Draw it out and boom. That's how it's done. That is how it's done. Nice. Okay, let's move on to the next problem. On the same set of axes, graph and label QRS, Q prime, R prime, S prime, the image of QRS after a dilation with a scale factor of 3/2 centered at the origin. So when your dilation is centered at the origin, it is super easy, all right? It's super duper easy. The reason is because all you have to do is multiply the coordinates by the scale factor. So what we're going to do is write down our Q coordinate, our R coordinate, and our S coordinate, all right? And then we're going to multiply those by our scale factor of 3/2, and then that will give us Q prime, R prime, and S prime. And remember, this only works if it's centered at the origin. When it's not centered at the origin, well, it's a little bit more difficult. So let's talk about how to do this. So what we're going to do is write down our coordinates. Q is at -2, 2. R is at 2, 0. And S is at, what is that, 4, 1, 2, 3, 4, 5, 6. So that's 4, 6. We're going to multiply each coordinate by 3/2. So you can put this in the calculator, or you can do it mentally. 3/2 of -2 is 3, -3. 3/2 of 2 is 3. 3/2 of 2 again is 3. 3/2 of 0 is 0. 3/2 of 4 is 6. And 3/2 of 6 is 9. So I just multiplied every single coordinate by 3/2. Multiply by 3/2, multiply by 3/2. All right, so now we're just going to go to our new coordinates. Let's do this in blue. Q is at -2, is at -3, 3. So Q prime is up here. R prime is at 3, 0. So that's our R prime. And then we have S prime at 6. So 9. That would be right here. So that's S prime. We draw it, and look, our triangle, that is such a terrible drawing. I'm sorry about that. Our triangle is now dilated. It got 3/2 bigger, or 1.5 times as big. All right. Oh my God, this first coordinate's wrong. Hold on. Let me just move this over. I'm so silly sometimes. Not there. That's 3, 3. Okay. Now, it says use slopes to explain why Q prime R prime is parallel to QR. Now, I'll tell you this. All you have to say to this is, how do I know that these two are parallel? Well, you might remember this fact, that a dilation preserves slopes. Remember, when you dilate something, they're always parallel. So dilations preserve slopes. Therefore, Q prime R prime is parallel to QR. And that is all you got to do. All right. So for this last problem, this is a fun problem to do. I challenge you to do it on your own. But, you know, I'll give you a hint. If you're going to do it, it's probably going to look a little bit something like, I'm guessing it's going to look like this. And then, you know, that's just my guess. Anyhow, now to practice your skills, what I'll ask you to do is go to this last page and actually, let's do these together. So we're going to do these last page questions together. I'm going to do them super quick, all right? So let's check out some multiple choice questions so we can get good at this, all right? So for your first question here, it says, what are the coordinates of B prime C prime after BC undergoes a dilation centered at point A with a scale factor of 2? Now, here's the dilly with this. This center of dilation is not centered at the origin, so you have to do it a little differently, and I'll remind you how to do it. To dilate something not centered at the origin, first you count the distance to each point. So for example, to get from A to C, I go 1 to the left and 3 down. And you might remember this, but To now dilate it, I just have to go twice as far in each direction. So I start back at A, and now instead of going 1 to the left and 3 down, I'm going to go 2 to the left, and then 6 down. 2, 3, 4, 5, 6. And that's where C prime goes. It's twice as far. Now we could do the same thing for B. I go 1 to the right and 1 down. Now I'm going to go double the distance. So I go 2 to the right and then 2 down. And that's B prime. And so the coordinates of B prime, C prime, B prime is at 1, 2, 3, 4, 5, 2. And C prime is at 1, -2. Dope. Now, number 2 says the vertices of PQR have these coordinates. Under which transformation are the distances and angle measures preserved? So it's saying which one of these 4 is a rigid motion. So I'll tell you this. The first one, you'll see that these are being multiplied. That means this is a dilation. Remember, we have our K here. We have 2 different Ks, but it's being multiplied. That means it's a dilation. The next one also has a dilation in it because it's once again being multiplied by the coordinate. The third one also has the dilation in it because it's multiplying the coordinate. And only number 4 is the correct one, which is a rigid motion, because this is a translation. And translations are rigid motions. Rigid motion. So remember, a translation is just when you add 2 numbers to a coordinate. So the answer here was number 4. I recommend doing these on your own, but here we go. If triangle ABC is dilated by a scale factor of 3, which statement is true for the image of A prime, B prime, C prime? Which statement is true? Let's go through these. So I have my triangle. Now remember, strategy, draw the damn triangles, okay? This is a geometry course. You can look at these triangles. So what we're going to do is make up 2 triangles here. And I want you to figure out after the words which one of these statements is true. So we have A, B, C, and A prime, B prime, C prime. All right? Now I'm going to make up some numbers. Why don't we just make up some numbers? We have 2, 3, and 4. That's fine. And if it's dilated by a scale factor of 2, it's 4, 6, and 8. Now remember, the angles stay the same, so we'll just say they stay congruent, okay? Because dilations preserve angle measures. So now let's eliminate 2 answer choices. If you go through these answer choices and you look at 3 and 4, what it's saying is that the measure of angle A prime is 3 times the measure of angle A. That's saying that angle A times 3 gives you A prime, and that can't be true because the angles do not change. Same thing goes for number 4. It's saying 3 times the measure of angle C prime is angle C. But that's not true because they are the same. Angle A will equal angle A prime, and angle C will equal angle C prime. Angles are congruent to each other in a dilation. Now we have 1 and 2 to look at. If you look at number 1, it says 3 times A prime B prime equals AB. And let's test that out. It's saying 3 times A prime B prime, which is 4, is equal to AB, which is 2. Now that doesn't make much sense because that gives us 12 equals 2, which is not true. So we'll try the last one. It says B prime C prime equals 3BC. Now if you look at BC, B prime C prime, that's 6, and it's, what's it called? Sorry, the scale factor was 3. Oh my God. Guys, I'm so off my game. I'm not even going to re-record this. Just let's rewrite our numbers. All right? But the point is, so B prime C prime is actually, give me a second here. B prime C prime is actually what's called 9. And BC is 3, so that's 3 times 3. And so we get 9 equals 9. That is the correct answer. Okay. Now, next one. It says the image of ABC after the dilation of scale factor K centered at point A is ADE. So ADE is the image of ABC after a dilation. So ABC was like this, and then it was dilated, and we get our new triangle. It says which statement is always true. Now, it doesn't tell us what the dilation is. It's some random dilation. It says which statement is always true. So the first one says 2 times AB gives you AD, which would be true if the scale factor was 2, but we don't know that. The next one says that AD is perpendicular to DE. Now, that would be true if we know that AB is perpendicular to BC because the angle measure is preserved, but it never tells us that it's 90. It never says that. You can't assume it. So get that out of there. The next one says AC is congruent to CE. I don't know what that's about. And then the last one says BC is parallel to DE. And that we know is the answer. Because remember, dilations always create parallel lines because it preserves the slope. So BC and DE will be parallel to each other. Remember, dilations always make parallel lines. All right, for our final question. Which rotation about the center will carry a regular decagon onto itself? All right, rotation will carry something onto itself. You write the minimum rotation formula. The minimum rotation formula is 360 over n. We'll give you what the minimum rotation is. A decagon has 10 sides, so it's 360 divided by 10. That means you get 36. Now, that's the minimum rotation. So now we got to test out every other rotation. So remember, we can go another 36 degrees and go 72 degrees. And that's also going to map the decagon onto itself. We could go another 36 degrees and we get 108, and that will map it onto itself. We go another 36 degrees and we go 144, and that would map it onto itself. We go another 36 degrees and we get 180, and that would map it onto itself. And that means 1 and 2 are out because we never hit those numbers. We'll go another 36 degrees and we'll get 216 degrees, and that means 198's out. And let's just go one more 36 degrees and we get 252 degrees. Yes, that works. You could have also done 252 divided by 36. That's the only one divisible by 36. All right, guys, that's it for this level 1 review. You're welcome. Have fun. Oh, by the way, don't forget to kiss a cat and your mom.